One of the things I always like to do is give you real case studies. And of course, that's one of the reasons why I sometimes show movies, because there it gives you a much better idea of what these case studies really are like. And so as far as population ecology is concerned, I want to give you several cases of how populations and environments interacted with one another and what the results of it were. So the first of these is the story of the red-cockaded woodpecker. And one of the things that happened to the red-cockaded woodpecker is that there were biotic factors that were modified. Now, these are biotic factors that were to a great degree modified by us as humans, but nonetheless, it's modification of the habitat that created a problem for these woodpeckers. Now, it almost became extinct because of some of the practices humans enacted, and it wasn't really obvious that we were doing anything particularly wrong. All we tried to do was to work on fire suppression. Fire suppression means that when there is the chance of a fire, you make sure that the fire doesn't happen. That's really what you try to do. And so you enact, you put Smokey the Bear on the side of the road and says the risk for fire is high. That means that fewer people are going to be dumb enough to make a campfire or fling their cigarettes out into the bush than if Smokey the Bear wasn't there. Right? So you try and create a way to not have fires. The problem is, in some regions of the country, fires are actually a natural habitat occurrence. And as a consequence of having fire suppression, it changed the forest floor vegetation in the habitat of these woodpeckers. Now they need open flight paths. They want to be able to fly rather quickly through the forest, and they want to be able to see. Well, if you have a lot of undergrowth now that's growing up because there hasn't been a fire that's gone through for some time, then the woodpecker isn't going to be able to fly where it wants to, and it's not going to be able to see where the food is. Clearly those are problems. People then said, okay, well, these woodpeckers have now become almost extinct. We now know why. Why don't we fix it? So what they started to do is work with controlled burns. And these controlled burns are actually very useful because they do provide training for the fire department. They are allowing the fire department to engage in environmental management, which is a new dimension for a fire department. And this all worked out very well. So here you see the red-cockaded woodpecker, and it basically has the nests in these pine trees. Here you have the example with all this undergrowth, and this is a place where the woodpeckers cannot thrive. Now you have the controlled burn reducing the undergrowth, and you end up with a clear flight path. And so here you can clearly see there's a lot. It looks a lot more spacious than it did there. And so controlled burns turn out to be important for these woodpeckers. So that was a way by which we understood how the individual organisms dealt with their environment. We realized the cause of their decline, and we were able to fix it. And that really is a great example for how environmental policy can work. It even created jobs for people in the fire department to do these burns. And it was just an unreasonable fear for the natural types of fires that occur periodically that caused this. So once people understood, okay, these fires aren't a big deal, in fact, the environment may need them, then it was okay. So it needed a little bit of education and the management, the willpower to enact the management program. A not so successful story is that with the North Atlantic cod fishery. And one of the reasons why this was not so successful is because this made a big impact on the economy. And when you throw money into the mix, of how humans interact with the environment, then most of the time, up to this very moment, the environment is losing. And so when you look at what happened to the North Atlantic cod fishery, you have a really good example. All right, let's start you in on this. If you have a nice and stable population of cod, that would be a population that is following a logistic growth curve. then it would reach a carrying capacity. Now, if you want to fish, then you can, as long as you fish only to the point where you bring the population back to where it will grow back very quickly. And the fastest growth of any population occurs at about half the carrying capacity. So if you take the fish stock in the North Atlantic and you catch a whole bunch of these cod and you make sure that you're not going past half the carrying capacity, then the cod in their normal environment will start to grow very quickly back to the level of the carrying capacity within 1 or 2 seasons. I mean, it's literally, people have shown that it's a very quick recovery time. However, if you go below that, then you threaten the sustainability of the population. If you go much below this half the carrying capacity number, then you're not going to be at a stable growth rate. You're not going to get back to that carrying capacity, but in fact, you're going to reduce the population to where it is no longer able to recover quickly. So harvesting is okay as long as you don't violate this sustainability number that half the carrying capacity is. Now, if people realize this, then of course they should implement these policies. And no matter what happens, they should not go past this number. Because if you are interested in the longevity of a fishery, whether it's cod, whether it's sardines, whether it's tuna, whether it's anything, once you drop below that level, then you threaten the very existence of that fishery. So rather than having long-term sustainable use of that resource, you cut it off and you have nothing. Now, there are a lot of people who like to be fishermen, and that's their way of life, and that's what they want to be. And if just somehow they catch too many fish, they lose all that, then that's obviously not the right kind of policy. So just to eke out the extra buck during a certain year means you're going to destroy the fishery forever. Well, that sounds pretty strange. Does not sound like a good strategy, but that's exactly where we found ourselves. So population ecologists have figured this out, and the people who make these policies were advised by the scientists to figure this out, but then the policies were not adopted based on these sustainable standards. They were basically adopted to ensure that the fishermen vote for the politicians who interact them. See, this is where this voting comes in again. There was a very interesting development just early this year where the House of Representatives, this is our House of Representatives, they passed a resolution, and this resolution says that the Environmental Protection Agency should not have any scientists on the panel that determines threats to the environment, but instead that it should be only members from industry. So here is a panel, the scientific panel no less, the scientific panel of the Environmental Protection Agency, which is the kind of agency that would come up with these kind of data and recommendations. And we, as a House of Representatives, are going to decide that let's not have anybody on this panel who could actually tell us what's really going on. Let's only have the people who know about the industry numbers be on this panel. Because, so the saying went, people who are in science, they don't understand industry. And after all, we want more industry, we don't care about the environment. So that passed. That's House Bill 1422. You can look that up. And it's totally irrational and really pretty ignorant when it comes to creating policy. So this is the kind of stuff that would feed into a system that basically kills an industry. The estimates of cod stocks were too high, and people said that they were too high, but nobody would listen. As a consequence, they weren't really very good about enforcing policy. And they said, oh, yeah, this cod is not legal. The size isn't legal, but, that's all right. We'll let you off with a warning. And ultimately, it changed the fishery to where it collapsed. I mean, look at this. There's a fluctuation here, no doubt. But once you get past a certain point, it completely collapsed. What does this mean in real terms? If you look at cod catching places like Newfoundland and Labrador, if you look at the small islands off the coast of Newfoundland, St. Pierre and Miquelon, that's a French colony. If you look at Iceland, the country, all of those basically lost their livelihoods because most of them had cod fishery as their mainstay. That's what they were doing. And so Iceland, with a very small population of highly educated people, they said, we're going to change this right now. We're not going to catch any cod for, I forget whether it was 5 or 10 years. And then we're going to manage this exactly the way the scientists tell us to. And this was very unpopular at the time. But a few years later, once the cod fishery could come back around Iceland now, you found that they had cod again. So even though off the coast of North America you still don't have this set of viable cod, now around Iceland you start to see it again. And so about 3 years ago, the government estimated that the population was fluctuating and was down a little bit. So they cut the quota in half. I mean, literally, they got the data, and the next day the Ministry of Fisheries, he decided to cut the quota for the fishermen. Now, what do you think the fishermen did? You probably think they were very unhappy, right? Because that meant that they were going to have half as much money. And they were, but the government said, instead of having you flounder here, and pardon the pun, but instead of having you not have enough cod, we're going to increase some of your benefits, government benefits, and we'll tie you over, and then next year it'll be better. And next year was better, and so they basically, by skipping a year of normal catch, they were able to increase their quota the following year, so they did make the money back. But had they just kept catching that same amount, instead of reducing the quota, they would have destroyed the fishery again. So just because the ministry actually decided to follow the real data, they were able to fix it. And so this is something that governments have to do in real time, not based on politics, but in real time, based on the science. You sometimes have to make those hard decisions. Third case study. There is a plant that was introduced into the southern United States, and this plant was called kudzu. And kudzu was something that came from Asia, and the reason why they have it, just like we have ice plant in California, they wanted to prevent roadside and hillside erosion. And kudzu appeared to be a very good candidate because it spread very rapidly, and that's what you want for a plant like that. But then it spread beyond where it was supposed to go. And the reason why is because it was following this exponential growth. There was nothing stopping its growth. No natural predators. It had limited resources, perfect growing conditions, and you end up with kudzu overgrowing, literally like a mat, as you can see here, overgrowing trees. So basically, you have an opportunistically growing organism. It grows and grows and grows. Eradication is almost impossible because you can't just tear it out, and it's got root masses everywhere. It's just very difficult to eradicate. And here's what it looks like. I call this slide Kudzu Plant for All Seasons. It is very, very rapid. So here you can see a shed in the middle of the forest. This is in the winter. Now you go to spring and you see everything starting to green up. And that's pretty normal, right? You expect things to become green in the spring. But now look at what happens in the summer and what happens by fall. That kudzu overgrows everything. I mean, it's totally, if you lay down in the spring and didn't get up, you'd be overgrown. I mean, it grows very fast. I mean, you can measure its weekly growth in inches. It's that fast. So what has happened in the United States is that kudzu and pieces of it were inadvertently transported all across the country. So it was this is sort of the center of distribution. It was in places like Mississippi, Alabama, and parts of Georgia. That's where it started, and it's been carried all over the place. Look at that. This is in Oregon. I mean, it's been traveling. Now there are places where it won't go. It won't go here because that's desert, right? So there's a limit to where it can go. But it has been able to get along certain rivers, upriver, perhaps with boats. You know, somebody parks their boat somewhere. It grows a little kudzu on it. They load up the boat on the trailer. They drive it to where they want to go fishing and plop it under the water. Now the kudzu has just traveled 500 miles, right? That's the kind of stuff that happens. So what do you do when something like this is basically overgrowing the country? And if you go to places like Alabama and Georgia, you can see these kudzu plants covering everything up. Well, it turns out that there is perhaps a solution in the offing. There's a fungus, and this fungus causes a disease in certain weeds that are related to kudzu. And people were able to figure this out. Now, the question, of course, is A, can this kill kudzu? And B, can we be absolutely sure that it doesn't kill anything else? Because then you make the problem only worse, right? If it doesn't kill the kudzu, but it kills other stuff, then what have you done, right? So this is obviously a very tricky issue. Now, people did these tests, and they did this in very controlled environments so that you have this fungus in the lab, and you're very careful that it doesn't get out. And they infected the kudzu with this particular fungus, and it worked. So now, if you are going to do this in the lab, let's do it in a controlled plot outside, but in a very controlled environment. And if that works, then perhaps we can spray it in other places. And of course, you have to make sure that it doesn't actually create a problem for anything else. So what you do is you get a hold of this fungus and you use a particular wetting agent. And with that wetting agent, then you really kill things off. And it turns out that it is a kudzu only problem. So ultimately, maybe kudzu is something that we can now solve, this kudzu problem, without damaging anything else in the environment. All right, that's the end of chapter 19.